இல்ல வேற PPT வந்துருச்சு. இது ஸ்டார்ட் பண்ணது இது இப்போ இதில் ஸ்டார்ட் பண்ணிக்கலாம் இல்லையா? So today we are going to discuss about carbon and its compound. That day I told you what is the speciality of the carbon. Even it has the atomic number 6. The electronic configuration is 1s2, 2s2, 2p2. So it has the valency is 4. Valency is 4. And then it has the special property that catenation. So why it has a catenation property? Very good. Since it is a catenation property. Since it has a smaller size and absence of p orbital, and then moderate electronegativity. These are the reason which behind that the carbon it will form carbon, 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 even it will form like that chain or a branched chain. It will form a ring like that. Okay, so we are studying in the special under the chemistry is known as organic chemistry, which is made up of the carbon only. So carbon and its compounds means we have variety of organic compounds, which is very much useful to us, since we know that our body is made up of mostly carbon. Okay, so if you take the enzymes, which is made up of carbon, hydrogen, oxygen, sulfur, like that, proteins, carbon, and then or the body flushes, it will made up of carbon only. So whatever the food we are taken, that is a carbon. So we have to study about the carbon. How we can classify that compound? Generally you can classify compound to open and closed. For the open, you can classify into based on the functional group, you can have the variety of compound. That day we discuss about how to name the alkane, alkene, alkyne, how to differentiate that and all. So when you take the hydrocarbon, so what is hydrocarbon? When the carbon with the hydrogen is hydrocarbon. When it's open chain, open chain, open chain, and then cyclic. The open chain, it will classified alkane, alkene, and then alkyne. The cyclic, it will classify aliphatic, aromatic, and then non-aromatic, like that. So alkane means when the carbon have the general formula of CnH2n plus 2. Alkene means it has a general formula CnH2n. Alkyne, it has a general formula CnH2n minus 2. All are open. So the name, it will be end up with ANE, ENE, YNE, ene. So it has a carbon-carbon single bond. It has carbon-carbon double bond. It has carbon-carbon triple bond. So these are the important factors. Here N will start with 1. Here has to N to start with 2. Here it will start with 2. So this is how we have classified. When it aliphatic, the cycloalkanes. So cycloalkane, alkene, cycloalkane, alkene, and alkynes are called aliphatic. So for example, cyclopropane, cyclobutane, cyclopentane, cyclohexane, cyclohexene, or cyclohexane, like that. So it will coming under the aliphatic. Aliphatic means alicyclic compounds. So this is called alicyclic compounds. And aromatic, aroma means smell. Aroma means smell. So smell giving compounds. Okay, like benzene, toluene, naphthalene balls. Whatever we are using, that balls, mouth balls. Is there no? That is naphthalene, anthracene. So these are, it has only carbon and hydrogen only. Whatever I am writing here, all is made up of carbon and hydrogen. So here we are saying aliphatic aromatic. That terminology we will learn later. Okay. Now, how we can classify the compound into different categories? So based on the functional group. What is functional group? So functional groups are nothing but these are the group which is responsible for the chemical reaction. The functional group which is responsible for the chemical reaction, which is responsible for the further chemical reaction in the compound. Further chemical reaction. They call it as functional group. So the generally how we can say the functional group. Number one, it started with haloalkanes. Halogen. That means the carbon which is connected with X. So that X may be chloro, bromo, fluoro, chloro, bromo, iodo, whatever it may be. Okay, and then first one, alcohol. That means OH. And then ether, OO. And then carbonyl compounds. In the carbonyl compounds, first we will have the aldehyde. Aldehyde means C double bond O H, or otherwise CHO. And then ketone, C double bond O, or we can write CO. Okay, could you see that? No? And then carboxylic acid and its derivative. The first, carboxylic acid, which has the functional group C double bond O OH, or otherwise COOH. Okay, and then ester, C double bond O O dash, or COO. And then amide, yeah. amide, C double bond O, C double bond O, NH2, or CONH2. Okay, and then anhydride continues. C double bond O, O, C double bond O. When the two acids are combined, it becomes anhydride. Okay, anhydride. And then carboxylic acid, ester, amide, anhydride, acid halide. COX. That X may be fluorine, fluorine. Hello? Okay. Thank you. நான் முடிச்சிட்டு பேசுறேன் மேடம். Fluorine, chlorine, bromine, and iodine. It whatever it may be. Generally, the fluorine they will not take. So the carbon fluorine bond is tight. So they will have chloride or bromides. Iodine is a larger size, they will not take. Whatever the functional group available, that I am writing. Okay, which is applicable, we can take that. And then nitro compounds. The chain which is related with the NO2, nitro, and then amines, NH2, then cyanide, C triple bond N, or nitride. Thio compounds, then we can classify many ways. See, that means functional group means if you have a compound like this chain, suppose it has COHs ending, then this compound is called aldehyde. So this is the functional group. When the reaction, the further reaction which is mainly with this. So apart from this, the secondary functional group, whatever we can say, double bonds, triple bonds, that will be the secondary group. And the group which is replaced in that, based on the type of reaction, we can say whether it is a substitution reaction or addition reaction, we can say, or it is a elimination reaction. Substitution reaction means you have to substitute one by another. Addition reaction means you have to add the substance to that. So the reaction which is brought about by the reagent, if undergoing a addition product, then it is addition reaction. For example, you have carbon-carbon double bond. Okay, that means next slide we will go. You have a CH2 double bond CH2. When I am adding hydrogen, what will happen? It become CH3 single bond CH3. So what happened? You have the same carbon skeleton, but you added 2 hydrogen on that. So the addition, the molecular weight get increases. This is known as addition reaction. So I'm having CH3, CH2, Cl, ethyl chloride. Okay, I'm heating with the base, whatever the base. I'm getting CH2 double bond CH2. So here minus HCl is went away. Then it is known as elimination reaction. So I'm having CH3 ethane. I'm putting chlorine in presence of light. I could be able to isolate the CH3 CH2 Cl. Then it is known as substitution reaction. One of the hydrogen gets substituted by this. So majority of the organic chemistry. So these are the 3 major reaction takes place. Somehow you have the rearrangement. Rearrangement is nothing but reorientation. So the one group which will migrate from one place to another place in the same molecule, that is known as rearrangement. There is no change in the molecular weight, but change in the 3 dimension. So this is what happened in the organic chemistry. First of all, we should know this functional. Once you know the functional group, their chemical properties will become almost same. For example, I am taking formaldehyde. It's aldehyde. I am taking acetaldehyde. It's aldehyde. I'm taking propanaldehyde. It's also a same thing. So everything which will react with the, I mean, RNH2. So what it will give, no? HC double bond NHR. So what about this? CH3CH double bond NHNR. So this will give CH3 CH2 CH double bond NR. So what is the difference? So it will form this bond. The remaining group will be substituent. Say, look here. Am I right? That CH maintaining, CH maintaining, CH maintaining. Only. So this is the group which is responsible for the chemical reaction. That's why we are saying this as a functional group. It will be a function. Okay. So you may ask, sir, why not this? So primarily it will do the functional reaction. Then only if you are altering any condition, then only the reaction will go this side or this side. The reaction has to, you have to provide that necessary condition for that particular reaction. Otherwise, the reaction will move. So it will based on the main functional group. Now here we are going to learn about the homologous series. So many of the organic compound which follows the homologous. What is homologous series means? It has certain rule. As like we are studying gases means these are the gas which has to follow this rule. For example, Boyle's law, Charles law, like that, so many laws will be there. If it is follows, we will say it is a correct one. Same way, if you have a solution, if it is, it turns this condition, then it become a good solution. Like that, that organic compound, it satisfy the following condition, then it is called homologous series. So what is the difference between these three? First, you take that example itself. You look at the formaldehyde, one carbon is there, acetaldehyde, two carbon is there, propanaldehyde, you have three carbon. So it will be a series. Now, what is the difference between first and two, one and two? What is the difference between two and three? Hmm. Hmm. Second is two carbon. Hello, CH3, CHO. CH3, CHO. Two carbon only is there, no? So what is the difference between these two? Between these two, you have one CH2. Between these two, first methyl, first methyl. In the aldehyde, what is the difference? So the difference is CH2. I'm writing the next member of the same group. So 4 carbon, it should be no. So what is the difference? What is the difference? So again, the difference is CH. So if the compound next carbon or next compound between the next two carbons, so what we can say, you have the series, first two have the difference in CH2, the next two have the same difference in CH2, each will vary by the CH2. The first member and the second member having the difference in the CH2, then it is called homologous series. So these are the compound which can be prepared by the similar properties, similar method. So when you have the method, I'm preparing a compound, I'm taking a compound, I'm adding sodium hydroxide, gives that aldehyde. Same method I'm applicable to the next one. If you take the alcohol, first I take methanol. Second, I will take ethanol. Third, I will take propanol. You know that 1 carbon means 2 carbon means eth, 3 carbon means prop, 4 carbon means but, 5 carbon means pent. It will go as like that. Okay. So methanol, ethanol, butanol, pentanol. So the difference between first and second member CH2, second and third member CH2, third and fourth member CH2. No problem. So if I'm preparing a method, I'm taking a methyl chloride, so I'm adding sodium hydroxide, so I could be able to get methanol. Then second also can be prepared by this method. Third also, what you have to take? Instead of methyl chloride, you have to take the ethyl chloride. And then third one, you have to take the propyl chloride, butyl chloride. If it goes, it will give the product like that. So the homologous series are nothing but these are the series of compound which can be prepared by the general method, and it should have the general formula. So what is the general formula for that? CnH2n plus 1 and OH. You substitute for that. When you put n was equal to 1, what you will get? What you will get? When n is equal to 1 means what is the answer? When n is equal to 1 means T1, hello, H2n plus 1. T1H OH. N is equal to 2. H5 OH. You calculate this one. CH3, CH2, 2 carbon, 5 hydrogen, and 1 OH. Same thing is there, no? When you put the 3, what you will get? This one. 4, this one. So it has a general formula. So it should, the homologous series means it can be prepared by general method of preparation. General method of preparation. And then it should have the general formula. And then what else? So it should be vary by CH2. So the physical property vary based on the structure. So, but generally, whatever you are expecting, increasing order, decreasing order, that will be there. The melting point will increases because the carbon number get increases, or carbon number get decreases. That's why it has the property like that. That will be there. But it should follow the things. Are able to understand? First, you should know the functional group. This one you should know familiar. When the carbon chain is connected with X, then it is called halo compounds. So, what is the formula for methane? CH4. You are replacing one nitrogen and you are adding chlorine, then it becomes CH3Cl. CH3Cl means methyl chloride. Is it okay? So when you have the ethane, C2H6, you are replacing one nitrogen and it will give C2H5Cl, ethyl chloride. So suppose you are having a methane, you are replacing one nitrogen by OH, methanol. You are having 2 carbon, ethane, you are replacing one nitrogen by OH, it is ethanol. So when you have the alcohol, the name will end with Al. Okay, methanol, ethanol, propanol, butanol, OL. So the name will end with the OL. So what is that halo alkane or whatever it is? taken, no, that will. When you take ether, which is nothing but when the oxygen which was bind between or flanked between two carbons. The two carbon may be open chain or closed chain, one open chain, one closed one, or both are closed one, ring. Okay, so then it is called ethers. So in previously it was used in the anesthesia. Operation பண்றதுக்குலாம் யூஸ் பண்ணிட்டு இருக்கு. So what will happen when the ether become like this? So two R groups. Alcohol, you can write ROH. So R is the organic part. Carbon. That may be this alkane, alkene, alkyne, aliphatic, aromatic, whatever. These are the R groups. R groups. Okay. So when the R groups linked with X, haloalkenes. If R is alkane. If R is alkene, haloalkenes. R is alkynes, haloalkynes. R is aromatic, haloarenes. That's it. Are you able to understand? When the ROR, then it is called ether. It is called ether. And the carbonyl compounds, which is known as aldehyde, or C double bond OH. When the compound is ketone, no, R C double bond OR. So the carbonyl group is flanked between two R. The carboxylic acid is RCOOH. And ester is R. Ester is R. C double bond O R dash. And amide is R CONH2. Why am I putting double bond O? No, CONH2 means commonly instead of here you can put R groups. That's it. Okay, unnitrate means R C double bond O C double bond O R dash. You may ask, sir, how you are remembering this one? Because generally it will happen. So nothing but COOH. Okay, anhydrate. What is the meaning? Anhydrate, acid anhydrate. Sorry, it's acid anhydrate. That means when you are taken the acid, if you are removing the water between the acid, so you are removing H2O, then it becomes COOC. That is anhydrate. Clear? Acid halide means RCOX. If you are putting Cl, acid chloride. Bromine, acid bromide. Fluorine, acid fluoride. That's it. Okay. And then nitrocarbon, it become RNO2. Amine become RNH2. Cyanide become RCN. So RNC is isocyanide. Bhopal isocyanide. Okay. So like that it will go. So when the R is, what is R? R is the organic part. Whatever you are seeing, that organic part is R. So this is the functional group of your compound. First, you should know this. Then only it will become easier. Next, so I told about the homologous series, no? Examples for the homologous series examples: alkane, alkenes, alkynes are one of the examples for the homologous series examples. Okay, not it will with alkane, alkene, alkynes. It will extend to the alcohol, aldehyde, ketone. It has to follow this condition. So you may suppose some of the compound will be prepared by one method. The same method will not be applicable for the next one. Means you should not take this is not homologous series. No, if we have some general method of preparation, it becomes homologous. For example, formaldehyde can be prepared by reducing the or removing some hydrogen from the methanol. You could prepare or oxidizing methanol. It will always, methanol means what is that? CH3OH. When you are oxidizing, it will give the formaldehyde. Okay, but it won't stop with the formaldehyde. Again, it will give the formic acid. Generally, that oxidation takes place. For the oxidation of methyl alcohol by some of the catalysts give the formaldehyde. It is not necessary condition that ethanol also will follow the same. It is not necessary condition, but it may or may not contain general method of reaction. Either one method வந்து same ஆ இருக்கும். Not for all the methods. Some method will be common, but it has to definitely, it should vary by CH2 and it should have the general formula. These are the definite ones. And the general method, one method will be general. The remaining will be the different methods. Different method is the Kaushik can prepare one method, Vignesh can prepare one method, Ritik can prepare one method. So it's based on the conditions. Okay, and then the molecular nature. If you take the methanol, it has one carbon. When you are going to this ethanol, it has two carbon. So the next problem, steric factors are all involved. So it won't go fasterly. Okay, so that also plays a matter. So we have to think that also. Okay. Now, so we will go for how to name the organic compounds. So there are certain groups which will give an idea about to name the organic compounds. So what is that? Generally, in previous, how they did the naming, no? They will take the organic compound from which source it's getting, then they will name it that source itself. For example, from the ant, they are getting the acid that is known as formic acid. The formic in the Greek means, Greek or Latin, the meaning is ant. Okay, so like that they will give the name. For example, vinegar, acetic acid, and then tamarind, tartaric acid. From the milk, lactic acid. So lactam is present, that's why they said lactic. Okay, so from which source they are isolating, they will give the name. For example, from the butter, they are isolating butyric acid. So they say it is a butyric acid like that. Okay, so it will give the naming. Malic acid is there, but not from like this. Malic is a general name only, but it is not a IUPAC name. So some of the scientists sit and come to the conclusion that we have to formulate some naming for this. So that is known as IUPAC, International Union of Pure and Applied Chemistry. Many scientists, they will formulate rules, nomenclature, to nomenclature the organic compound or to nomenclature the inorganic compound. They will decide a rule that is known as IUPAC rule. So according to the IUPAC rule, for naming the organic compound, you have to choose longest chain. Choose longest chain. Okay, even if you are having branching, which chain is the long? For example, I'm having C, 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 C. Is there no? So I can give number 1, 2, 3, 4, 5, 6 or 1, 2, 3, 4, 5, 6. If you don't have any substituent, so whatever numbering it is suitable. All the numbering is suitable. In case if you are having branching C, 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 I'm writing this. So if you are giving numbering, for example, I'm giving in the red number 1, 2, 3, 4, 1, 2, 3, 4. So I'm telling that. So the lowest number is bottom one. So second position I'm having the substituent. So second substituent and butane. If I'm saying that, then it will become wrong. So which is right? So when you are numbering 1, 2, 3, 4, 5, 6 or 1, 2, 3, 4, 5, 6. So the top number only you have to take because third only you have the substituent. When you are coming from the bottom one, fourth one having the substituent. So which is the nearest one, that substituent only we have to take. Then according to that, first it is a 6 number. Previously it was 4 number. So 4, 6, which is the longest? So you have to choose a longest chain. And then branching should be nearest number. Branching should be in nearest or lowest number. What I'm meaning? What it meant? That numbering. So you can have 3 and 4. You have 2 options. Which one you have to choose? You have to choose a smallest number. For the branching, you have to choose a smallest number. Okay. And then first substituent at branching. If you have 1, no need to name that. Directly name. Then you have 2, you have to say die or by. When you have 3, try. 4, tetra. For example, no need to write. It understood you have 1. For example, I'm writing CH3, C, CH3, CH3, CH3. If I'm giving the numbering, it can be 1, 2, 3. Either case, it will become same. So you have the second portion only 2 methyl group. You should not write 2 dimethyl propane. You have to write 2, 2 dimethyl propane. Simply if you are writing, it is a isobutane. It's a common name. Iso means branching. Totally, I'm having 4, 1, 2, 3, 4, 5 isopentane. I'm extremely sorry. Isopentane. So instead of isopentane, you can write IPEX name is a 2,2-dimethyl propane. You look that CH3, CH2, C, CH3, CH3, CH3. Then CH3, CH, CH3, CH, CH3, and then CH3. Now you see, when you are giving the numbering, it become 1, 2, 3, 4, 1, 2, 3, 4. And then 1, 2, 3, 4, 1, 2, 3, 4. So which number we have to take? Okay, what is this rock? Which number we have to take, ma? So generally name means total how many carbon? 4 plus 2, 6. Then isohexane. Okay. So it become isohexane. It become isohexane. Both you can name it as isohexane. Whereas it will not be the same case. But the two compounds will be different, right? Two compound will be different. How to name that? Based on the IUPAC. So you can take the bottom one because the branching will be nearest in the bottom. What about the second and second compound? Both are same only. You can take either above or below. So according to that, second portion only you have the substituent. For the first compound, I'm writing 2, 2 dimethyl. How many remaining? 2 methyl you are mentioned. Remaining 4 carbon. Then what is that? Butane. You have only carbon single bond. And when you are coming to the second one, this one, You look at 2, 3 dimethyl butane. So both are different only, right? First one 2, 2 dimethyl butane. Second one 2, 3 dimethyl butane. What it inference you are getting? So in the first one, the second carbon itself, you have 2 methyl group. In the second one, you have methyl will be in second and third position. So this is 2, 2 dimethyl butane, 2, 3 dimethyl butane. This is how we have to name it. So this is for the alkanes, alkane. So this is for alkane. Suppose I'm going for the alkenes. Now CH2 double bond CH2. CH3 CH double bond CH2. And then CH3 CH2 CH double bond CH2, or CH3 CH double bond CH single bond CH, right? Look here. First one, the carbon CnH2n, right? When I am giving n is equal to 2, it becomes C2H4. So alkenes are carbon-carbon doubly bonded. Alkenes are carbon-carbon doubly bonded. When you have carbon-carbon double bond, totally how many carbon is there? So the name should end with E and E. So 2 carbon, eth and ethene or ethylene, ENE. So when you are coming here, how many carbon is there? Then what is the root name? 3 carbon means prop. So you have in propene. So suppose the double bond between these 2 carbon means CH2 double bond CH single bond CH, right? You can give the naming. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That means so either it between 2 and 3 or 1 and 2. Here 1 and 2. In the bottom 2 and 3. So both are same the compound only. So according to IUPAC name, you have to choose the nearest one. When the double bond is there means which is the nearest number, 2 or first carbon itself you can take. That bottom is correct. For about this, the top one is correct. You name the first one. So totally 3 carbon. At first carbon you have double bond. It become 1 propane. It become 1 propane. When you write the second one, you tell me. You see the double bond between first and second. Then it become same only. Both are same only. It's a 1 propane. So same way we'll go for the next one. 1, 2, 3, 4. 1, 2, 3, 4. Which one we have to take? Numbering. Top one or bottom one? Then you tell me totally 4 carbon. Bute. Bute, where the double bond will be present? Between which carbon? In the top means how you can 1 and 2. 3 and 4. Then what is the name? Bute. That ene present in which carbon? Third carbon. Then as per your statement, it becomes 3 butene or bute 3 ene. What you said, the double bond is present on the third carbon. But I am saying these two are wrong. The name is 1 butene. It's the correct one. Or bute 1 ene. Why it is correct? Why yours is wrong? Where you made mistake? Where you made mistake? You think and tell me tomorrow. You think now itself. See, CH3, CH2, CH double bond, CH2. So what I said, numbering 1, 2, 3, 4, 1, 2, 3, 4. So whenever you are choosing a number, it should be lower to yours, which is the nearest one, which is the lowest one. That's it. That carbon-carbon double bond is the primary. Okay. So based on what you have to identify, so which we are choosing as a primary one, that only we need to identify. Here, carbon-carbon double bond is the choosing factor. Then you have to say this will be the thing. Okay. So we will continue tomorrow. Any doubt is there? Second unit. Then third we have to start. Or first we have to start. Third. We will revise the previous year questions. Okay. Doubts at that. Sodium hydroxide terms around the station. Hydrochloric acid. All of them are that. HCl gas does not change the color of dilation treatment paper. When you dissolve into the water only, the hydrogen ion. Okay. So HCl gas dissolved in water present in the litmus paper only forms. HCl gas was the gas dissolved in the water. Only turn the color, litmus color. So A is correct. HCl gas does not change the color of dry, correct. Present in the wet mix. Only A is true. Okay. But it is not the explanation for that. It's not the explanation. That is true. Yes, it will change the color of the text. Wait, only. Dissolve the water. Formation. It gets dissolved in the water only with formation. A or is like A is not the explanation. So the option B. Error B. Error B1. Or is the correct. How you can use so they have given HCl gas. Here HCl dissolved in water. Right? The chemical formula of basic observation. compound excess sodium and excess sodium that very good. What are the a solution of pH 2 is present to separate a few drops of methyl how will you how will the color of indicator change? Numbering as very good. Maybe the transparent acid very good. So methyl acid it was a yellow color, orange or yellow color acid. And you're putting the sodium hydroxide. Please remember, either methyl or phenol. When it is present in the basic medium, it becomes okay. So other now basic medium rating. Whatever you are using becomes okay. So if someone suffering from the problem, okay. So how much is it and how much is it? So the remaining will be correct. So you happy with that? What about biology? This is a full can say you will but then I you will and that up you have to get into okay. All the best. What are we going to do there? What are we going to do there?